Hi, I'm back to do another video on solving absolute value equations. As we saw from the first one, there's a possibility of two solutions. Now if you saw the first example, we have just a little refresher. When we have the absolute value function, the general function is a function that looks like this, more or less, as I get used to this pen and tablet here. So that's the general, or the parent function y equals absolute value of x. And what we're going to do now is take a look at a more challenging example, one where we have the absolute value of 3x plus 2 equal to 4x plus 5. Please excuse my writing. I'm not used to this outfit just yet, but we'll get there eventually. So as we see over here in the graph, we see that for positive values of x, the y values are positive, and for negative values of x, the y values are also positive. So there are two cases, one where there's an x where the x values are positive, and one where the x values are negative, or basically where the modulus is positive, because the x is in the absolute value bracket, and here where the modulus is negative, meaning it's inside the absolute value. So if we take a look at the two cases, here we've got case 1, where 3x plus 2 is positive. Then, because when it's positive, we don't really have to do anything with this because we know that the values are just going to remain positive. So 3x plus 2 equals 4x plus 5. And then we just have to solve this. So we subtract 4x from both sides, so we end up getting negative x. We subtract 2 from both sides, so we get 3. And then we multiply both sides by negative 1 to get x equals negative 3. Okay, so that's case 1. Case 2 would be when what's inside the absolute value is negative. So when 3x plus 2 is negative, or less than 0. So if this were the graph of just y equals x, where x were negative, y would also be negative. And as we discussed in the first example, the way to make these negative y values positive would be to multiply it by negative 1. So what we'll do is we'll take this, because we're saying this whole thing is negative, so we'll multiply that whole thing by negative 1, so we get negative 3x plus 2, and that equals 4x plus 5. We'll multiply through by the negative here, so we get negative 3x minus 2 equals 4x plus 5. And I'll subtract 4x from both sides, so we get negative 7x. I'll add 2 to both sides, so I get 7, and then divide both sides by negative 7, so you get x equals negative 1. Now we just have to check, in this case, because the right side is also a function. In example 1, we just had a constant, 5. But in example 2 here, we've got an actual function. So we have to make sure, we have to see when this whole thing is going to be positive, because we know that the modulus of 3x plus 2 has to be positive, so we have to see when this is going to be positive, this 4x plus 5. So we'll just check down here, so we have 4x plus 5 is positive, and we'll just solve for x now. So we subtract 5 from both sides, so 4x is greater than negative 5, and x then is going to be greater than negative 5 over 4. Okay, so it's going to be smaller than negative 1. And we see we've got it's going to be greater than a value that's just a little bit smaller than negative 1. So if x has to be greater than a value very close to -1, we see that x equals -1 could probably work. I mean, it is in that range where x is greater than -1. But this value of x equals -3 is not in this interval. So in this case, will not get two correct values like we did in the last example. We'll only get one. And in this case, we'll see that because x has to be greater than -5/4, x equals -1 is greater than -5/4, therefore x equals -1 is the solution. Again, I'm going to apologize for my horrible penmanship here. Now, if I go over to the graph to take a look at what that looks like, we see that here's the graph of y equals 4x plus 5. Here's the graph of the absolute value of 3x plus 2. And we see that they intersect at -1. Now, if we were to kind of zoom back a little bit here, we see that these graphs are never going to intersect again, because this graph of 4x plus 5 is steeper than this part of the absolute value function. Therefore, there will be no other intersection points. Therefore, this is the only intersection point at -1, 1. And so therefore, x equals -1 is the only solution in this case. Thank you for watching, and we'll see you in class.